All right, section 8.6, solving rational equations. And so a rational equation has at least one rational expression and has at least one variable somewhere in the denominator. We're going to look at solving some rational equations as well as some that are slightly easier, just to help build back some of those skills to make sure we're ready to do this. So let's just start off by solving a rational equation using the graphing calculator. To solve using a graphing calculator, you want to graph each side of your equation separately and then find the intersection. And so when I say graph separately, what I mean is you're going to be plugging this into like the y1, y2 lines of your graphing calculator. So you go to the y equals screen and you graph them. So essentially on y1, you're going to put 4 over x minus 2. Make sure you use your parentheses accordingly. And then on y2, you're going to put x minus 1 divided by x minus 2. And so, like I said, use your parentheses. So like parentheses here, here, and here. And then we would graph this and then find the intersection. So to find the intersection, we know that this is going to be our second, and then our trace. And then we're going to choose the intersection option from that menu. And we're going to choose both of our lines, line 1, line 2, and then our guess. And then in this case, we should get that the intersection occurs at x equals 5 in this case. So for our x value, our intersection occurs at 5. And so that's using the graphing calculator. It's really quick, really easy, but in this case, that's what we're looking at. And since we're only looking for the value of x, we only need to know x equals 5. If you find your intersection point, it's 5, 1.33, or 1 1/3, but in this case, we just need the x value. All right, so let's talk about solving algebraically. So to solve algebraically, we're looking to, essentially for a lot of these, just clear all denominators. In a lot of cases, you'll have to factor the denominators to find your least common denominator. You'll then multiply both sides of your equation by that least common denominator to clear out the denominators, simplify, solve, and then at the end of this, you always want to be checking for extraneous solutions. And some of these steps, like, we're not always going to have to factor things out. Sometimes they're just set up easier for us. Just depends. But the ultimate, the bigger rational equations, you're going to have to factor some things out and find your least common denominators. All right, so let's look at that same problem we just saw a second ago. Let's solve this one algebraically without our graphing calculator. Well, this one is actually fairly easy to do. Our denominators here are the same. So ideally, we don't have to multiply by anything. We can just ignore them for now. So 4 equals x minus 1. To solve this, we would add 1. And then in this case, x equals 5. If we plug this back in to check for extraneous solutions, we have 4 over 5 minus 2 equals 5 minus 1 over 5 minus 2. Well, this is 4 over 3 equals 4 over 3. Well, that's good. So 5 works. All right, in this second problem, we've got 2x plus 1 over 6 plus x over 2 equals x minus 1 over 3. So in this case, the least common denominator should be fairly obvious. Well, we've got 2, 3, and 6. 2 and 3 both go into 6, so the least common denominator in this case would be 6. So what we want to do is we want to multiply the entire problem by 6. And so what this does is it's going to cancel out, in this first one, it's going to cancel out the denominator, so we've got 2x plus 1. In the second one, we have 6x divided by 2, that becomes 3x. And then here we've got 3 goes into 6 twice, so this becomes 2 times x minus 1, which we can simplify in a second. And so ideally what we're going to do now is, since we're done with the denominators, we just want to solve. So here we'll combine our like terms. This is 5x plus 1 equals, let's distribute, 2x minus 2. Bring the 2x over, this becomes 3x. Subtract the 1 equals negative 3. Divide by 3, we get x equals negative 1. So now we just need to check for extraneous, so we would plug this back in. And so plugging in negative 1, that's going to give us negative 2 plus 1 is negative 1 over 6 plus negative 1 over 2 equals negative 2 over 3. Well, in this case, if we put common denominators here, this is negative 1/6 plus negative 3/6 equals negative 4/6. And I can see this already works, so we're good. So this is a good solution. All right, so let's look at another examples. Here we've got 2 over x plus x plus 2 over x plus 1 equals negative 2 over x squared plus x. Let's just go ahead and rewrite this so we can get a better idea of what our least common denominator would look like. So 2 over x plus x plus 2 over x plus 1 equals negative 2, and we can factor the bottom into x times x plus 1. So now if we look here, we have x in the denominator, we've got x plus 1, and then we've got the combination of the two. This is our least common denominator. So what we want to do is we're going to multiply everything by that. So we're going to multiply both sides by x times x plus 1. So we've got 2 over x plus x plus 2 over x plus 1 equals negative 2 over x times x plus 1. And we can go and put this on this side too. And so what we're going to see is this cancels. This cancels with this. And so we'll multiply the 2 times the x plus 1. So this becomes 2 times x plus 1 on top. And then for the next one, kind of have to, oops, not that. When we go back to the drawing board here, we see that the x plus 1 cancels with the x plus 1 here. So the x gets multiplied by the top. So that becomes x times x plus 2. And then here, this whole bottom piece cancels with this, so this just becomes negative 2. So now what we really need to do now is just kind of clean this up. So we've got 2x plus 2 plus x squared plus 2x equals negative 2. Let's combine our like terms and let's clean everything up. So we've got x squared, we've got plus 4x, and then we've got plus 2 equals negative 2. We can bring the 2 over by adding it. So since we're dealing with a quadratic, we need set equal to 0. So plus 4 equals 0. So what we're going to do with this is we want to factor this now. So x squared plus 4x plus 4 equals 0. Factor this, you've got x plus 2 and x plus 2 equals 0. Well, in this case, I know right off the bat that x equals negative 2. And of course, we want to check for extraneous. In this case, when you plug it back in, I'll just tell you now, this one works, this is good, and so you're all set. These problems do take a little bit longer. You're going to see that you're going to need a little bit more space, but just try to keep track of your work as you go. All right, so let's look at another one. So 5 over x plus 9 over 7 equals 28 over x. So in this case, we've got an x, we've got a 7, and we've got an x. In this case, the least common denominator is just going to be 7x. So we need to multiply the entire problem by 7x. So we're going to take 7x times 5 over x plus 9 over 7 equals 28 over x, which we're going to multiply by 7x. Let's write it on both sides for fun. And so here, the x's cancel, so it's 7 times 5, which is 35. Here, the 7's cancel in the second set, so it's 9x, so 9 times x. And then 7 times 28 in this case is, in this case, 7 times 28 is 196. All right, and so now we just solve this. We'll subtract 35. We've got 9x equals 161. And then we're going to divide by 9. In this case, x should equal 17.8 that repeats roughly. Here we've got x plus 6 over x minus 5. Well, there's only one denominator in this case, so the least common denominator is pretty easy. It's just x. So we've got x plus 6 over x equals negative 5. So here the x's just multiply together. We get x squared. For the second quantity, the x and the x on the denominator cancel out, so this becomes 6. And then negative 5 times x is negative 5x. The presence of the x squared makes this a quadratic, so we want to get everything on one side. So x squared, we'll add the 5x over, plus 6 equals 0. This is factorable, so it's going to be x plus 3, x plus 2 equals 0. So in this case, I know right now that my answers are x equals negative 2. Well, let's line them up. Let's do negative 3, and then x equals negative 2. So there are my solutions. So now I just want to check for my extraneous. Well, so extraneous means plugging it back in. So let's just start with the negative 3. So we've got negative 3 plus 6 over negative 3 equals negative 5. Well, this is negative 3 plus negative 2 equals negative 5. That's good. Let's try the negative 2. So negative 2 plus 6 over negative 2 equals negative 5. This is negative 2 plus negative 3 equals negative 5, so that's good. Both of those are good solutions. Question 6, we've got 5x minus 2 over x minus 4 equals negative 3. Once again, we're dealing with another situation where there's only one denominator, so this is actually pretty easy. We're going to multiply both sides by x minus 4. So this is our least common denominator. So when we multiply here, this just cancels. So we've got 5x minus 2 equals, and then negative 3 times x minus 4. So we're going to go and distribute this. So 5x minus 2 equals negative 3x plus 12. Then we just want to solve. So we'll bring the 3x over, so this becomes 8x. We'll add the 2, so this becomes 14. We'll divide by 8. And we should get, in this case, x equals 1.75. And if we plug this in, this works. Keep in mind that the last two problems we've done, we could be solving these graphically as well, but I prefer to solve things algebraically. You can use the graphing calculator to do a lot of these, but we're just looking at these algebraically. Here we've got 15 over x plus 9x minus 7 over x plus 2 equals 9. So in this case, we've got denominators here of x plus 2 and x. So what we need to do is we need to recognize that our least common denominator in this case is going to be x times x plus 2. We're not just going to use just the x plus 2 because, it has an x in it. That doesn't work that way. In this case, x and x plus 2 are different quantities, so we have to account for them together like this. So we're going to multiply both sides of the equation by this. So we're going to take 15 over x plus 9x minus 7 over x plus 2 equals, equals 9. And so with this, for the first quantity, the x's cancel, so we're just going to take 15 times x plus 2. And then for the second quantity, the x plus 2's cancel. So here we've got x times 9x minus 7. And then in the back half here, the 9 gets multiplied by both of those. So it's going to equal 9 times x plus 2. So we're going to have quite a bit here to simplify, but we can take care of it. All right, so here we're going to start, just distribute this. So this is 15x plus 30. We'll distribute the x here. So that's 9x squared minus 7x. And then here, I'm going to make this 9x. And so we're going to distribute the 9x throughout. So that's 9x squared plus 18x. All right, and so now we want to get everything to one side in order to solve. Since we've got those x squareds, let's move those first. So let's move the 9x over. 9x squared, that is. Well, this is going to give us 15x plus 30 minus 7x, which I guess we could have combined like terms here. So 15x and the minus 30, that's just 8x plus 30 equals 18x. From here, we want to divide by 8. Not divide by 8, sorry. Here we want to subtract 8x. There we go. Subtract 8x. I know I was forgetting something. And we've got 30 equals 10x. We're going to divide by 10. And we should get that x equals 3 in this case. So what we're going to do then is we're just going to plug this back in and test for extraneous solutions. So let's see, if 3 is our value, we've got 15 divided by 3 plus 9 times 3 minus 7 over 3 plus 2 equals 9. So this is 5. That's 27 minus 7 is 20 divided by 5, which is 4. And so 5 and 4 is 9. 9 equals 9. We're good. Good solution. This time we've got 7x plus 3 over x squared minus 8x plus 15 plus 3x over x minus 5 equals 1 over 3 or minus x. So in this case, we do have some factoring we have to do to simplify in order to know what our greatest common factor or least common factors are. So let's just start by factoring this guy here. So the top's going to remain the same, so 7x plus 3 over, in this case, this is going to be x minus 3, x minus 5, plus, and then we've got 3x over x minus 5, doesn't change, equals, and let's go ahead and pull a negative 1 out of the bottom so this looks better, so negative 1 times x minus 3, so that way it matches our other factors. So with this, we should now see that we should see our least common denominator now. It should be, in this case, exactly what we have out here in front. Let's change the color. There we go. X minus 3, x minus 5. So we're going to multiply both halves of this problem by that value, or both halves of the equation. So we've got x minus 3, x minus 5, times all of this inside. So 7x plus 3 over x minus 3 times x minus 5 plus 3x over x minus 5 equals 1 over negative 1x minus 3. So in the 1 and the negative 1, we could put the negative on top if we really wanted to. But we're multiplying this out to try to see if we can't cancel out those denominators. And so in this case, this quantity cancels with this, so we're just left with 7x plus 3. And then the next one, only thing that cancels is the x minus 5, so this becomes 3x times x minus 3. And then for the last bit, the x minus 3 cancels with this. And so then that leaves behind negative 1 times x minus 5. So like every other example we've done, we've got to clean things up a little bit. So 7x plus 3 plus 3x squared minus 9x equals negative x plus 5. So I want to combine like terms and bring everything to one side because we have that 3x squared there, so we're going to have to account for that. So in this case, we're going to bring it all over and clean it up. So we know it's the 3x squared out in front. We've got 7x minus 9x is negative 2x, and then we're going to add over an x. So that's just negative x when all is said and done. Then 3, and we, in this case, subtract the 5. So that's negative 2 equals 0. So at this point, I want to factor this. So I'm going to bring this back up here. So 3x squared minus x minus 2 equals 0. To factor this, you could use slide divide, you could use grouping, guess and check, but I know that this factors to be 3x plus 2 and x minus 1. And that equals 0. So in this case, when I solve this, I get x to equal negative 2/3. Here I get x to equal 1. And then we're just going to check for extraneous. All right, let's look at one more kind of like this last one where there's a little bit of extra work. Sorry about the disorganization. Good. Hopefully you're more organized than I am. Let's look at one more. So this time we've got x over x minus 3 plus x over x plus 3 equals 2 times x squared minus 9. All right, so just like everything else we've done, we're going to probably have to factor part of it. In this case, I know I have to factor this piece here. So I've got x over, and let's kind of skip a step here, x over x minus 3 plus x over x plus 3 equals 2, and this is the difference of squares, so x plus 3, x minus 3. And so here I can see that my least common denominator is just going to be this value here. So what I want to do is I want to multiply the entire equation by x plus 3, x minus 3. And I'm actually going to rewrite this so it looks a little nicer because that's a little messy. Bear with me one second. So we're multiplying by our least common denominator, so x plus 3, x minus 3, and then we're going to multiply the entire equation by that. All right, and so with this, we should see in the first set here, the x minus 3's cancel, so we're left with x times x plus 3. In the second set, we move over, the x plus 3's cancel, so this becomes x times x minus 3. And then at the end, both of them cancel, so it equals 2. And so now we just need to clean it up again. So this is x squared plus 3x plus x squared minus 3x equals 2. Combine your like terms, you've got 2x squared equals 2 because the 3x's cancel. And so we'll divide by 2. And so x squared equals 1. Then we square root. And so in this case, x is going to equal plus or minus 1. And in both cases, we can test for extraneous. If we want to, we can test right now. So for 1, we've got 1 over 1 minus 3 plus 1 over 1 plus 3 equals 1 over, or sorry, not 1, oops. That's 2, 2 over 1 minus 9. So this would be 1 negative 1/2 plus 1/4 equals 2 over negative 8, so that's a negative 1/4. And so in this case, a negative 1/2 plus 1/4 is a negative 1/4. So this works out for 1. And then I can tell you right now that negative 1 also works. All right.